Okay, what is displacement reaction? Displacement reaction you learn in periodic table topic. It's actually the more reactive element pick up or displace the less reactive metal ions or element from the compound. So for example, let's say if you have magnesium add to copper 2 sulfate, magnesium is actually more reactive. The more reactive must be the element. Okay, more reactive must be the element. Okay, then copper is the less reactive. Less reactive must be in the compound. Okay, less reactive is compound. More reactive is element. Then the more reactive will kick out the less reactive, then itself will become compound. So it forms magnesium sulfate and the one kick out will left alone. So you get copper. Okay, so more reactive must be element, then kick out the less reactive from the compound. Then itself become the compound. That's all. So because everybody wants to become compound, that's why I did. Okay, if vice versa, if you put the less reactive one as element, more reactive in the compound, then nothing will happen. That's the idea. Okay, so that's displacement reaction, same as periodic table also. Except periodic table is halogen displace halogen ions. Metal here displace metal ions. Okay, then for displacement reaction, what do you need to know? First and foremost, of course, is something we call rank reactivity. Rank reactivity means what? Means they can give you some information, and then you're supposed to know from the information which method is more reactive than which. Give an example. Let's say if they say X plus Y nitrate, then they say you get X nitrate plus Y. Okay, Y plus Z nitrate, nothing happened. Then Z plus X nitrate, you get Z nitrate plus X. So X, Y, Z, which one is the most reactive metal? Which one is the least reactive? Sometimes it can ask you to rank the order. So how do you see? Very simple. You see, if the element can displace the one in the compound, it's more reactive. If cannot, means less reactive. So the first equation, X can displace Y, because you get X nitrate and Y, right? So that means X is more reactive than Y. Okay, the first equation tells you that. Then second equation, Y plus Z nitrate, nothing happens. That means what? Y cannot displace Z. So Y is less reactive than Z. So from these two equations, Y is less reactive than X, Y is also less reactive than Z. So Y must be a least reactive metal among the three metals. Right, then Z and X, which one more reactive? The last equation tells you Z plus Z, X nitrate, you get Z nitrate plus X. Means what? Z can displace X. So Z is more reactive than X. So Z is the most reactive metal, followed by X and Y. Okay, so this kind of question very important and very common in O level or N level. So you need to make sure you know displacement reaction. Okay, besides rank reactivity, the other one you have to know is observations. Okay, observation means what will you see? What do you observe? What do you hear? Those kind of things. That's called observation. So if they ask you what do you observe in the reaction, don't say I observe magnesium sulfate and copper form. Cannot. Because if you have something, the solution, how do you know it's magnesium sulfate? Right? If you have a solid, how do you know it's copper? You cannot observe identity. You can only observe things like color, right? Things like smell, right? Things like feel hot or cold, those kind of things. So observation for displacement reaction, mainly there are two. Okay, one is the color change to solution. The other one is the color of the metal that's formed or that's being displaced, so forth. Okay, for the case of color of solution, the key thing is to know the ions color. For metal ions, okay, in the reactivity series, very easy to remember, only a few are colored. What are the few? Iron 2. Iron 2 is what color? Green. Then iron 3 is what color? Yellow in solution. But if it's solid, solid is actually reddish brown. Okay, then copper 2 is what color? Blue. Okay, the rest colorless in solution. Okay, of course, if it's solid, it's white. That one only say white is solid, colorless in solution. Okay, so if we take this example, use this example, right? Copper 2 sulfate, the solution is copper 2 sulfate, become magnesium sulfate. So copper 2 sulfate is what color? Then what is the ion inside? Copper 2 ions. Right, copper 2 sulfate and copper 2 ions. Copper 2 ions is what color? Blue, right, in the compound. Right, copper 2 ions is blue. So you will see the blue solution turns what? Then you see the final compounds. What is the metal? So in this case, the metal is magnesium. So magnesium ion is what color? Colorless in solution. Right, rest is colorless. So you'll see the blue solution turns colorless. Right, if it's iron 2 sulfate, then you turn green. That's all. So you just see what's the metal in the compound, and then what's the metal in the products compound. Then you will know what's the color change. Then color of the metal form, of course, is the copper here or other metal. Metal's color, okay, it's not ion's color. Metal color very easy to remember. Copper metal is reddish brown. Okay, reddish brown. Okay, other metal in the Recti series, all just put gray and already. It's just different tone of gray. Like silver is what? Silvery gray. Okay, take note, there's no color called silver. Okay, when we say something, your iPhone is silver in color, it means the color look like silver's color. Okay, in actual fact, the color code there's nothing called silver color. Silver is what color? Silvery gold, silvery gray color. Gold is what color? It's not gold color. Gold is shiny yellow color. Right? Okay. So reddish brown for copper, the rest is gray. So in this case, if it's copper form, then you say what? Reddish brown, solid deposited. Okay, so that is for the observation part. And of course, equation and rank rapidity. Issue more important.